This is it, the stuff that somehow governs what we are.
Hey everyone. Prepare to meet an animal that seems almost alien. A true marvel of evolution. Hiding beneath the waves. It has 3 hearts, blue blood, no bones, and a brain that wraps around its throat. Oh, and it can taste with its arms, disappear in plain sight, and might be one of the smartest creatures on the planet, outside of us vertebrates. This is the octopus. These incredible mollusks, part of the Cephalopod class, alongside squid and cuttlefish, took a radically different path from their shelled ancestors. Losing that protective shell millions of years ago seems to have kick-started an evolutionary explosion of ingenuity. Camouflage, jet propulsion, ink defenses, and perhaps most fascinatingly, a highly complex intelligence. Today, we are investigating the biology and the truly remarkable mind of the octopus. Let's explore this enigma of the deep together. One of the octopus' most famous tricks is its camouflage. It's not just changing color, it's a masterclass in mimicry. Their skin contains thousands of tiny pigment sacs called chromatophores, controlled directly by nerves. They can expand or shrink these sacs in milliseconds, creating intricate patterns and shifting hues instantly. Below that, iridophores, which act like tiny mirrors, creating iridescent blues and greens. And deeper still, leucophores, which provide a white canvas, helping to match the brightness of their background. But, and gets even better, they can change their skin texture using tiny muscles called papillae to become bumpy like a rock or smooth like sand. It's active, dynamic camouflage, unlike almost anything else in nature, requiring sophisticated visual processing and neural control. And when camouflage isn't enough, they move. Their main escape tactic is jet propulsion, sucking water into their mantle and blasting it out through a siphon, shooting them backwards at impressive speeds. But for everyday exploring, they use their 8 arms to crawl gracefully along the seabed, like multi-limbed explorers. Oh, yes, the arms. 8 of them, not tentacles. Each arm is a marvel of engineering. A muscular hydra stand incredibly flexible and strong without a single bone. And those suckers, they're not just for sticking. Each one is packed with chemoreceptors, allowing the octopus to literally taste and smell whatever it touches. Now, here's where it gets really wild, neurologically speaking. An octopus has a large central brain, donut-shaped around its esophagus. But that's only part of the story. Roughly 3/5 of its 500 million neurons are located out in the arms. Each arm, essentially, has its own local processing centers, chains of ganglia controlling movement and processing sensory input locally. This leads to this idea of the octopus having 9 brains, 1 central and 1 mini brain in each arm. It allows for incredible multitasking and local control. An arm can be busy figuring out how to open a shell, while the central brain is watching out for predators. It's a completely different model of intelligence compared to our centralized system. How does it all coordinate? That's still a big question for neuroscience. So, this unique biology supports some truly impressive cognitive abilities. Octopuses are fantastic problem solvers, and labs They quickly learn to unscrew jars or puzzle boxes to get food rewards. They navigate mazes using landmarks, even learning routes using the touch input from just one arm. And what about tools? For a long time, tool use was considered a hallmark of higher animals. Then came the veined octopus. Researchers observed them collecting discarded coconut shells, carrying them awkwardly across the seabed, sometimes using this funny still-walking gait, and then assembling them later as a portable shelter. This deliberate transport for future use is widely considered strong evidence for tool use in an invertebrate. Even more surprisingly, there's evidence octopuses might play. In controlled settings, after exploring a new object like a bottle, they have been seen repeatedly pushing it around with jets of water, almost like bouncing a ball, long after they have determined it's not food nor a threat. This seemingly purposeless, repetitive behavior fits the definition of play, suggesting a capacity of intrinsic motivation and perhaps even positive emotional states. Their learning abilities are also remarkable, especially considering their generally short lifespans, often just 1 or 2 years, and the fact they get zero parental guidance after hatching. They demonstrate clear, associative learning, linking visual or tactile cues to rewards or punishments, and they seem to recognize individuals. Studies with the giant Pacific octopus showed they could learn to distinguish between different human caretakers based on how they were treated, showing preference for the nice one, and avoidance or even squirting water at the annoying one. While recognizing other octopuses might be less developed, this ability to learn and remember individual humans is pretty astounding for a mollusk. There was even a famous, though sometimes debated, study suggesting octopuses could learn a task simply by watching another octopus do it first. If true, that would be incredibly advanced for an invertebrate. So, what does all this tell us? The octopus mind evolved entirely separately from ours for over 500 million years. Yet, they arrived at complex cognitive abilities like problem solving, learning, memory, tool use, and maybe even play and individual recognition. This is a stunning example of convergent evolution. It suggests that intelligence isn't a single invention, but something that can arise whenever evolutionary pressure demanded. For the octopus, losing its protective shell likely created intense pressure from predators and forced it to rely on wits, camouflage, and behavioral flexibility to survive and hunt in complex marine environments. Their unique distributed nervous system is the hardware that evolved to meet these challenges. They are not feathered or furry. They don't live in complex societies like primates or crows. Yet, they demonstrate a form of intelligence that is both deeply alien and strangely familiar. They force us to broaden our definition of what a mind can be. The octopus, a creature of incredible biological ingenuity, a master of disguise, an 8-armed problem solver, perhaps even a player. They are a reminder of the vast diversity of intelligence on our own planet and how much we still have to learn about minds different from our own. Studying them doesn't just teach us about octopuses. It teaches us about the very nature of cognition and the myriad ways life finds to be smart. What cognitive ability of the octopus impresses you the most? The camouflage, the tool use, the learning, the potential for play. Share your thoughts in the comments below. Thanks for joining this dive into the octopus mind.
What do you mean?
Heard of you? Who hasn't heard of yogurt?
Yogurt the wise. Yogurt the all-powerful.
Yogurt the Magnificent.
Please, please, don't make a fuss. I'm just plain yogurt.
But you're the one...
Yes, I am the keeper of a greater magic. A power known throughout the universe as the...
The Force?
No, the Schwartz.
Schwartz.
Yes, the Schwartz.
But yogurt, what is this place? What is it that you do here?
Merchandising.
Merchandising? What's that?
Merchandising. Come, I'll show you. Open up this door. Come, walk this way. Take a look. We put the picture's name on everything. Merchandising, merchandising, where the real money from the movie is made. Spaceballs the T-shirt. Spaceballs the coloring book. Spaceballs the lunchbox. Spaceballs the breakfast cereal. Spaceballs the flamethrower. The kids love this one. Last but not least, Spaceballs the doll. Me.
May the Schwartz be with you.